I'm very excited to be here today. I'm very excited to hear this presentation that you have for us, Mr. LeClaire. The first time and only time you gave this presentation was to NASA in 2001. Is that correct?
Yeah, that's correct. It was back in July of 2001. I was at a nanotechnology conference actually right here in the state of Maine in Portland. And I met Bonnie Dalton, who is the acting chief of life sciences back at NASA Ames. And so I described to her a theory that I've been working on since 1996, that cavitation is the phenomenon that created all the molecules of life and actually assembled all of the life forms as well. And she was very intrigued, so she went back and talked with the headquarters of the NASA Astrobiology Institute is at NASA Ames. And they're very interested, so they ended up flying me out there on a NASA grant through the Maine Space Grant Consortium. And in July of 2001, I presented my cavitation theory to the top minds in the astrobiology community. At the time, Barry Blumberg, the Nobel laureate that won the Nobel Prize for the hepatitis C virus and vaccine, was the director. And it was very well attended. There was probably maybe 150 astrobiologists and life sciences specialists there from NASA.
Wow. So just for the people that are just tuning in now, could you give us a very brief summary of what cavitation is and what makes the LeClaire effect so special before we get into the real juice here?
Well, even well before I discovered the LeClaire effect, which creates cavitation, fusion, and transmutation, I just noticed based on the geometry of cavitation, and cavitation, by the way, is a boiling phenomenon. So in water, you're forming a steam bubble, and then the steam bubble collapses near an object and forms a reentrant jet. And the jet is formed when the bubble turns itself inside out like a donut, like a torus, and then the core of the torus is actually launched towards whatever is restricting the collapse. So if it's a flat plate, it'll go directly towards the plate. And so I noticed in the course of trying to harness that jet for nanotechnology fabrication purposes that a crystalline form of water had been formed. And the crystalline form of water also can be seen to spiral at times. And it was pretty obvious from the fossil imprints that are left behind that it looks very similar to DNA. And so back in 2001, even before the discovery of the crystal, I could see from the photographs that were taken from professors in the field like Lauterborn that it had a spiral geometry to it that was not just very similar, but actually identical to RNA and DNA in terms of being what we call congruent, so that the spirals have the same ratio of pitch to strand thickness. So it turns out that happens to be the same as it is for a liquid jet. And so the rest of the theory is that cavitation formed a template, which later on was reinforced by the discovery of this crystal. And this actually acted as a template, a scaffold to assemble both RNA, DNA, and also different types of proteins, including alpha helix and beta sheets. And so cavitation, interestingly enough, had the right stuff. In conjunction with that, it also produces a lot of very interesting chemical reactions and is the basis of what we call sonochemistry. And so sonochemistry shows us that we see accelerated chemical reactions. Some of them can be 100,000 times the normal rate. So the combination of these things is what led me early on in 1996 to formulate the theory. And I've been developing it ever since, and most recently the discovery of cavitation, fusion, and transmutation fits in very elegantly with the theory. And in fact, there's always been a great deal of synergy between those discoveries. And the result is that when you're producing all the elements that you need right there, at the same time you're producing the template. And this solves another fundamental issue, which is how do you get elements heavier than iron, which aren't produced in stars, they're only produced in supernovas. How do you get those into the picture? And of course, right now the current wisdom is that nearby supernovas scattered their remnants, and that some of that ended up in the primordial mix when the solar system formed. But the reality is that cavitation, fusion, transmutation is so potent that it would vastly overwhelm the amount of heavy elements in the ocean. And the gist of it is that cavitation is being created in the ocean by the impact of asteroids and comets. This is occurring during the very beginning when the oceans had just formed. And curiously enough, life had formed only shortly after the oceans had formed. And so this is something that always perplexes people now. Of course, when you're having these major bombardments, just to give you an idea how violent the primordial bombardment was, you had an object the size of 10 kilometers hitting every month, and of course, much more constant rain of smaller debris. And the result is you have rocks, chunks of ice, and other debris heading at high speeds through the ocean. And this leaves a trail of these cavitation bubbles behind it. It creates a boiling zone surrounding the object. And so all these cavitation bubbles are creating jets, and they're all interacting with each other. And so this creates a factory that generates life. It first generates all the precursors, all the chemicals that you need, and then through further activity, actually begins to do the assembly into viruses, bacteria. It's possible that cavitation created not even some of the very simplest life forms, but maybe archaea, bacteria, and also viruses, all of them together, that it was able to generate them from scratch.
Wow, wow. I didn't think it'd be possible to offend the Bible thumpers and Darwinists at the same time, but you just might be able to do that. Before we go into just how powerful this cavitation effect is and just exactly its role in evolution, I just want to introduce a good friend of yours, Noah Gang, who's joining us right now. Noah has done some excellent research with Dr. Gerald Pollack, as well as many others on easy water and magnetic fields with planar flatworms, etc. I believe they're the only worms that have nervous systems. So I'm very curious as to what your questions will be for Mark at the end of this and your insights on this, Noah. Thank you for joining us.
Thanks.
So Mark, I read your paper, and it's an amazing paper, absolutely astonishing paper. I just want to give people an idea of how powerful these cavitation effects really are. Could you go into that a little more?
Yeah, cavitation is a very violent phenomenon, and as you pointed out, the Darwinists all seem to think that life was created in a tranquil little pond, is the quote. And I'm saying that it was created in a maelstrom of activity, and that the one thing the chemists seem to leave behind is they think that chemical reactions only occur when you dump everything into a pot and you stir it up. But the reality is that there's a lot of things that are being driven by fluid dynamic phenomenon, high-speed motions like the cavitation jets through the water. These things have never really been considered in terms of looking at it from a prebiotic chemistry standpoint.
Okay, so every time an asteroid goes into Earth and hits the ocean, it's creating massive cavitation wave behind it, right? They say if
Well,
an asteroid...
it's not so much a wave, it's leaving a trail of trillions of small bubbles. And so, in fact, the number of bubbles is one of the things that's a clue, is that the ocean was saturated with micron-sized bubbles from cavitation pretty much constantly because of all of the impacts. And in fact, Barry Blumberg, that was the one thing that he latched onto, is he said that, he changed my perspective as to how the primordial bombardment really played into this, and that you couldn't get away from cavitation. It was prevalent, it was everywhere.
Wow, wow. So could you give us an understanding of the exact phenomenon? Because it's this little itty-bitty cavitation bubble, and it explodes or implodes in on itself with such force that describe the effects, the heat, etc., whatnot.
Yeah, I'm actually going to switch over to showing you a document here. Okay, so what we've got is this is a steam bubble that's being created. And in fact, let's see. This is a real life cavitation bubble right here. It's about 1 millimeter across. And it was formed by a laser pulse. And so the laser was focused just above the surface, because the idea was to form the bubble close enough to the surface that when this thing begins to first expand and then collapse, the collapse is trying to pull away from the plate. It's being held back by a suction surrounding the plate. So this is just a steam bubble surrounded by water. Okay, and so as the bubble begins to proceed collapsing, if it was off in the middle of nowhere, it would just collapse to a point and then disappear. But because it's collapsing next to an object, that restriction on the collapse slows the collapse of the bubble down on that side. But on the opposite side, it's free to collapse up to the speed of sound in the liquid, which is 1,500 meters per second in water. That would be Mach 4 in air. So it forms a jet pointed down towards the surface, and this can strike at up to 1 mile per second. So it's really moving and highly energetic. Cavitation, the final point of collapse, pressures as high as 10,000 atmospheres and temperatures as high as 250,000 degrees Fahrenheit form on the final stages of collapse. The bubble can actually emit X-rays from the violent plasma that's inside the bubble. Okay, and so this is the basis of being able to form what we call a reentrant jet, because the flow flips around 180 degrees, and then the jet is actually the core of the inside of this torus that forms. So you can see it right there. That's the actual liquid core, and surrounding that is steam. So this is the idea, and you can see how flat the top of this thing is. I mean, very bizarre mechanics and cavitation collapse.
Wow, so from this humble little water bubble, you get Mach 4 speeds, supernova type temperatures, and when it implodes in on itself, it collapses, it shoots a jet of water at the nearest object, and that's where the magic happens?
Yeah, that's right. In fact, I'm going to also bring up another picture here that I want to show, because I think this will help clarify. Let's see. Okay, so what we've got is I'm kind of superimposing a image of cavitation bubble. This is what I've drawn on the inside to show you the dynamics. So the bubble is turning itself inside out. The jet is coming down through the core of the bubble, striking the nearby surface. What's happening is it's forming a spiral template, because jets, as they move, like to go into this spiral motion. It's an instability that we call the Kelvin-Helmholtz instability, but it's a natural action for these things to want to spiral. And so it turns out that because of the high pressure, that it's actually forming a crystallized version of water. And the spiraling jet that comes down oftentimes is a hexagonal or even a trigonal crystal. And if we look down here at the pictures, then what we see is that this is one of the plates with a hole in it that I formed a bubble next to. And these trenches are actually hexagonal trenches.
Wow, so it's making hexagonal trenches into the metal. It's that powerful.
Yeah, it's cutting right into the steel. And so, in fact, you can see that it's forming closed loops too. The crystal can actually link into a closed loop. And this is one that's actually embedded itself into steel. What you're seeing is a figure eight that's collapsed. And you're seeing a bunch of sequences of hexagons, because this is the cross section right here. It's typically a hexagon. Excuse me 1 second, I'll take a glass of water. So here's another example of what I'm talking about. So you can see the figure eight. So that one actually formed a loop, twisted into a figure eight, and then electrostatically embedded itself into steel. That's because the crystal is powerfully charged with positive charges on the sides and on the end. And it often will form, it'll have a fat head at one end, which you can see here. And then, excuse me. And so this is able to form a closed loop, and you can actually see this trench. One of the crystals is the head is trying to join with the tail. It actually formed a perfectly circular trench in a plate of aluminum. That's 1/8 of an inch across. And in this picture on the right-hand side, what you see is a bunch of diagonal slashes. That's in the lower right-hand corner shot. And you can see that the crystal in that case was spiraling along the surface, so it was cutting into the surface and leaving a series of parallel grooves that were diagonal. And so it's pretty clear that cavitation jet has the right stuff in terms of being a spiral geometry.
Hey, Mark, can I interrupt a sec? Is there a way you can make the pictures bigger
Yeah, there is. Sure, 1 second.
so it takes up the screen? Because we have some people are saying it's a little small for them to see.
Right.
This spiral shape is a big part of the puzzle, right? It allows the re-entrant jet to penetrate cellular membranes, thereby affecting the DNA within cells. Is this correct?
Well, it's mostly because it can form such a small diameter strand when it hits. In fact, It can go all the way down to 0.28 nanometers. Okay, I'm going to flip over to pictures again. All right, so some of these strands can go all the way down to 0.28 nanometers. So yeah, it's able to penetrate a cell, put a hole through the membrane, and can be used to do things like targeted drug delivery. That's covered in our issued patents. So you can actually aim this jet, load it with some material, send that into the cell. It could be just about anything. It could be a drug. It could be genes for gene therapy. And the idea is you're aiming now and being able to do this in vivo and keep the cell alive. All right, so
So it's fair to say that sonograms for babies are doing the same cavitation effect, affecting them at the genetic level.
yeah, that's a well-known phenomenon, in fact,
Yep.
and it's not a good thing. I've read close to 100 papers on chromosome damages in fetuses caused by diagnostic ultrasound. In fact, just to put it into perspective, one study that I read that was conducted at U Rochester, let me just flip back, said that they took a dish of bovine blood cells, that's cow blood cells, and they exposed it to diagnostic ultrasound levels for 2 minutes. And after that, 50% of the cells were mutated.
My goodness.
So it's, diagnostic ultrasound is powerful and it has a very negative effect on tissue as, it creates these jets.
So we've just seen proof of this in that these re-entrant jets can actually carve hexagonal swaths through solid steel. And by the same token, they can also pierce cell walls, which are very strong, but because they're such a fine needle, they can pierce and mutate cell walls.
Yeah, absolutely. I mean, oops, 1 second.
So this sounds like the foundation of your theory of life, this mutation, right? You would have to be able to explain this in order to explain how species can evolve, correct?
Yeah, it's a well-known fact that if you speed up the mutation rate, then you also speed up evolution. Because you're increasing the amount of variety of genetic material that's out there. And so the result is that you've got much more in terms of like different variations, and then nature does the rest by selecting for whatever will survive the current environment. So cavitation mutation really is a whole new chapter in evolution that's never been described before, and that's actually part of my dissertation on this. Is that afterlife form is also being heavily mutated by continuously being hit by other cavitation reentry jets once the cells and viruses form. So it's busy snipping away, DNA and other nuclear material. And the result is that you end up with a radically increased mutation rate. And in fact, I propose that had that not happened, we may never have evolved past single-celled organisms. That in order to go multicellular, maybe it requires constant exposure to cavitation for a billion years before it happened, because that's what happened.
Well, that's remarkable. From the humble little water bubble, we've just learned that you might not want to use uh, uh, those machines. What do you call those machines on your children? To ultrasounds. They might be quite harmful to children. So all mothers out there should be aware of cavitation.
Yeah, absolutely. I think that it's nothing to mess with. I mean, it's well known that it'll cause these mutations. Like I said, the blood that's being altered in that test that they did. What's the difference between that and the blood that it hits on the way through, your stomach? So not good.
Absolutely.
Okay,
So,
let me flip once again to another shot I want to show everybody, just so they can get a better feel for the crystal. Okay, so these are some of the impacts that I began to see, and if you'll notice, like this one right here is actually a hexagonal. And you can see facets in this impact, but this one on this side you can see is more circular. And there's
Can
also
you make
heat
those pictures
affected.
bigger, please?
Yep, I sure can.
Yeah,
Let's see.
thank you.
Okay, so this is actually an impact into a coin that I had, and so you can see facets here that are, there's a 120-degree angle right there between those facets. And then you come over to this one, and you can see that it's actually round. Here's another example of a hexagonal impact that it blew the material out. It actually created a heat-affected zone that was also hexagonal. Now look at this one. That certainly a liquid couldn't produce a triangular impact. And in fact, this is what I'm claiming is the basis of the crystalline structure of this thing, is that you're forming water into a structure that looks like, I'll show you. Flip back on the zoom here. Okay, so this is what I'm saying is actually the crystal. I'll blow that up. So this is what makes this different than easy water. I think Noah may want to really listen in on this part of it, is if you look at the cross-section of this thing, you're forming an equilateral triangle. What's happened is that you have oxygen, or the large atoms that are being shown, and then the black and the gray are actually hydrogens. And so you have one oxygen that's sitting here, its hydrogen is coming up out of the plane, and the next one goes towards the adjacent oxygen molecule, and so it forms a triangle of oxygen molecules like that, with the hydrogens spaced equally in between. Then the other hydrogen goes up above. So the net result is now this end of the crystal here is all hydrogens. And when you strip away the electrons from this, like it's surrounded by a plasma, then what you're left with is a bunch of positive nuclei, on the top end of this thing. And then along the sides, there's twice as many positive exposed charges as there are negative. So the result is there's a net negative, positive charge on the side, but on the bottom you have the oxygen molecule, and it's negative in terms of the orbital where the positive hydrogen would plug in. So the result is this thing can come all the way around, and it can form a loop. And so, let's see. So I think you'd seen the other earlier pictures of this thing. Oops. Sorry, this thing's got a hair trigger. But it'll have fossil imprints in itself. For instance, this one right here, you can see it has hexagonal head. And if you look closely, there's also a hexagonal bulb right at the bottom, too. And so, it's very interesting. It looks like a bacteriophage. It has a fat head to it. So you can see this showing up in different ways. In fact, some of the other impacts. Now, if you look at this one right here, we've got a red zone in green litmus paper. So this is showing that you get 0 pH because the positive charges of the hydrogens are actually going to give you an acidic face to the crystal. And I figured this out from the crystal structure. So I actually intentionally shot crystallized uranium jets towards litmus paper, and sure enough, it turned the right colors to show that it had 0 pH on the outside, that it was expressing a predominantly positive charge. And of course, as I pointed out in some of these other pictures, like the figure 8, it can actually form a closed loop. So the other important thing that distinguishes this crystal from ice is they're actually forming a link of atomic bonds from the oxygen molecules to the hydrogen molecules as you go along. So the result is along the axis here, you've got a series of hydrogen, oxygen, hydrogen bonds all the way down the length of this thing. And those are held together by what we call a covalent bond. It's very strong. But in the plane, it's actually hydrogen bonds that are attacking this thing together. That's only about 1/10 the strength of the covalent bond, like an oxygen-hydrogen bond. So the result is the crystal can actually peel apart like spaghetti. It's got a lot of strength along individual axes, but collectively together, it's held together by weaker hydrogen bonds. And so this puts the crystal into a special class. Chemists call that a van der Waals crystal because it's made up of both hydrogen bonds and regular atomic bonds. So it's a very exotic way of being able to put the water together. And the other thing to point out is that this results in a very high density because the triangular packing here is much more dense than water would be ordinarily. And usually the closest it gets together is a hexagon. So the result is this triangular form is only forming above probably 500,000 psi. So it takes a lot of pressure to be able to generate this crystal. And that's why typically it's not seen. And it also will convert back to ordinary water when it electrostatically embeds itself, into a nearby object, like it does in these pictures here, where you can see it embedding itself into steel. So you see a spot of water after the crystal will impact the target.
So this crystal is, I believe you said, 5 times harder than steel, correct?
No, it's 5 times more dense than water.
Oh, okay. But you said it's harder than diamond or something?
Yeah, it ends up being extremely strong because the triangle, as mechanical engineers know, is one of the strongest structures that you can produce. So the result is incredibly strong, and it's also very stiff. I've actually been able to calculate the stiffness of this. It's about 10 times the stiffness of tungsten, because you can impact it into an object and see the sine wave as it crumples. And from that, you can use this one equation called the Euler equation and back out the stiffness. And it turns out it's 10 times stiffer than tungsten, which is one of the stiffest materials there is.
Well, that's amazing. So it achieves this incredible density and stiffness, and then upon it losing its electrostatic charge, it just dissipates into water again, correct?
Yeah, and this is part of the missing link phenomenon I think that cavitation provides, is that, one of the big questions is, why don't we see it now? Why don't we see life being created, in the oceans just like it was back then? And the answer is that maybe it is being created, and who knows, maybe that's where some of these new viruses are coming from. It's just not happening at the same rate.
Conscious manifestation has a lot to do with the quantum entanglement of what's going to be created through the transmutation process that you're talking about. Having access to this technology means we as conscious beings have that responsibility and a legacy to bring forth of transmutation of whatever it is that we need in the environment, whether it's easy water, free power, whether it's cavitation, to create the transmutation. What you have there is exactly what you said, the theory of life, and also how quantum entanglement and the manifestation of consciousness.
Well, absolutely. In fact, one of the things I want to point out to the audience here is kind of to get back and give you a little primer on the cavitation fusion. I did some experiments. I'm going to show you a picture of the thing here in a second. Okay, so what we have is I took a piece of PVC pipe that was only a foot long, and I placed a rolled up piece of perforated aluminum plate, which you can see in the lower left-hand corner there. Okay, so this is the core of the thing. That's all it was, just a drilled out aluminum plate. And the reason why is because I noticed that the crystal will actually carve trenches along the rows and columns of the holes. And you can actually see in some cases it'll leave trenches that in the longest cases were up to 7 feet long in some experiments I've done with the wire. So the idea is that you want to provide electrostatic attraction of the crystal to the material, and then it'll begin to carve these trenches, because I think we're kind of skipping an important step here. Let me back it up here. Okay. So what's happened is that we've discovered that the crystal is actually heading towards the surface of, like, say, the aluminum plate. And what we typically see is that half the crystal will be out of the page and half of it will be into the page. And the result is that it forms a half hexagonal trench. So the crystal is actually heading, in this case, from left to right. And it leaves a half hexagonal trench behind it, if, of course, the cross-section of the crystal is hexagon. But this probably 80% of the crystals that I've observed were of that type. In fact, here's the first examples of the LeClaire effect. Now, these lines appeared like magic on the plate. In fact, I'll blow some of this up so you can see it better. So this is the case where I'm forming the cavitation bubble above the hole. The jets aim towards the hole, and then all of a sudden these lines appear out of nowhere, going all the way across the plate after only being in the bath for a few seconds. Nothing mechanical was there to be able to touch it, and yet there it was. And so this is what one of the trenches looks like under the microscope. You actually see, in a lot of cases, that it's half hexagonal. And then also, on the other side of the hole, some of the crystals came out and went into orbit around their own induced negative charge surrounding the edge of this hole. They're positive, the edge is negative. The result is just like gravity. So these things are orbiting like planets around the sun. So you can see, and in fact, you can see there's like the fat head too. They have a thinner tail behind them.
Well, so clearly the geometry of its motion is very seen constantly, right?
So like if you look, this is actually the inside of that same hole that you were just looking at, and if you look closely, there's three sides to these trenches, and there's a 120-degree angle between flats. So these were created by hexagonal cavitation reentrant jets that went through the hole. And if you'll notice, they each went side by side because I'm firing individual jets through here by pulsing the laser. So every time one of these crystals goes through, it's attracted to the sharp edge of the trench before it. And so each one is laid down side by side like this. It took me a while to really sort out what was going on, but it's obvious that it was electrostatic attraction.
Electrostatic attraction is key to the LeClaire effect, correct?
Yeah, absolutely. In fact, what's happening is that this crystal, which is powerfully charged with an electrostatic charge, that acts like a trigger and causes the crystal to actually accelerate and begin to be chased by its own bow shock, which is what we're seeing here. And so what's happening is the bow shock is negative because it's incandescent. It's going really fast through the material and the water. And the crystal is positive, so there's an electrostatic attraction between the two. But the really bizarre thing is that it's a runaway acceleration, and that this thing is accelerating apparently up to relativistic speeds because right in front of the shock wave here is triggering fusion. It's compressing the material in front of it, gives it the squeeze, and of course it goes through stages as it accelerates. And it's actually synthesizing the elements all the way up the periodic table as far as californium and probably beyond that. There's evidence that it actually synthesized the ununs because you see the daughter elements of unun decay. So this thing is actually, let's jump right ahead here.
So to give people an idea of what you're talking about, there's something happening here beyond fusion because of the heaviness of the materials being transmuted and appearing?
Absolutely.
I'd like to point something out. A lot of what you're showing, these tracks and marks, we see these same cavitation marks on planets such as Mars and Venus, as well as here on many of our ancient stone buildings that have showed the background carvings such as Pumapunku. Exact trenches, fairly similar, the dotting, the marring. We see cavitation tool marks on many of the ancient buildings.
Well, cavitation's been around for a long time, and, TechZ and I had a conversation once, and I felt that a lot of the ancient Arab alchemists were probably onto this, and a lot of the synthesis of elements back then could have been conducted by cavitation.
Absolutely agree. Alchemy is showing a whole new layer to science, and science is showing a whole new layer to alchemy. Now that we can share information publicly.
Yeah, and just to show you how powerful this effect is, I've blown this up. Now look what happened to that edge right there. Can you see it?
Yeah.
Wow, that's cool. Wow.
See, it's very rough, right? Look at the heat affected zone. See, there's like a series of like crescents. Looks like a serrated edge. The crystal is actually following the edge of this plate, all right, because it's electrostatically attracted to it. Carved a hexagonal trench right down the length of this thing, and each one of these pits is a small supernova explosion. Okay, and it's creating radiation that's so intense that it's creating diamond out of water. All this white debris that you see aside right here, see? There's like a circular pattern as well. In fact, I'm going to move right to the larger one here. Sorry. Look at this. This white patch right here is diamond. That was demonstrated by doing what they call XPS analysis. And it turned out it had the same binding energy as diamond. It wasn't ordinary carbon. And it also contained all of the elements. It gave off a lot of radiation. If you look at the top image right here, see the hole pattern? That's like a photographic image of the drilled out pattern in the plate itself that's been put there by the underneath plate because this thing's rolled up, right? And the radiation passing through each layer is projecting a diamond layer on the other plates. That's what you're seeing.
Wow, Mark, I just want to give people some perspective that if it was anyone but you and just watching this happen in water, it would just look like boiling water. But the reason you've been able to figure all this stuff out is because you can isolate each individual little bubble at a time and observe what's happening with that little bubble, correct?
Correct. In fact, if we jump back to the basic diagram here, so I'm forming the bubble with a laser. I'm concentrating the focus. So I'm going to place the center of that bubble exactly where I want it. And then I'm pulsing the laser, in some cases, one shot at a time. So I'll form one bubble and one jet. And then I'll see cause and effect so it doesn't create a mess on the workpiece here that I'm looking at. And so, it's very simple to follow cause and effect, whereas if this had been a pump, you'd have seen millions of these events occurring simultaneously, really messing up the picture. And that's what they call separation of variables in science, so that helped out a lot.
Okay, well, it sounds like you're a master class experimenter. So I just want to clarify for people, you've got 5 patents out, and the heart of your patents is that you can control this re-entrant jet and where it goes via the use of lasers, correct?
Yeah, I mean, the laser just happens to be nice if you're looking for precision, but some of the earliest stuff that we played with was actually electric spark, and it was like Dr. Frankenstein. I had this long switch. We'd hit the switch, and it would create a cavitation bubble that was so big it would blow a hole right through a bottle cap. In fact, yeah, we had some fun with that one. In fact, I ripped off my kid's Pokemon glass jelly jar, and I didn't really expect those.
Oh, no, you
And I
didn't.
didn't. Yeah, sorry, man. I killed Pikachu. But so we ended up putting the bottle cap in the bottom of the jar. I hit the Frankenstein switch. It sounded like a shotgun going off, and it blew the entire bottom of the jar off, just like it had been cut with a glass cutter from one jet.
Wow, so that's the power of controlled cavitation. Like we all have to respect that. I just want people to understand how amazing this effect is, and once you can actually observe it and control it, sky's the limit. So I just want to roll things back right now and give people an idea of how prevalent cavitation is in industry.
Mm-hmm.
So cavitation has always been seen as a nuisance, right? And propeller blades of boats, because it just degrades the propeller blade as it goes through the water, but it's also used in making, you said 80% of pharmaceuticals? How?
Yeah, I'm gonna share something with you here. Well, what you do is you form these jets inside of a optical chamber, and it launches the jet to a narrow bore tube. And I introduce material coming in through the side, and what it does, the jets, a million of these things are traveling a second down through the length of that tube. And the result is that it's like firing bullets down the length of the barrel, and anything that's in the way is broken up all the way down to the atomic level. And so that's really handy if you're doing, like, you see all these different processes that are listed. Anything from getting water and oil to mix, that could be diesel and water, forming very small particles for pharmaceuticals so that you don't end up plugging capillaries. They have to be really small, down, well below a micron in the nanometer range. Even paint, you don't want to have lumpy paint, so cavitation is used to produce that. I mean, it's been around for probably 70 years, and seen extensive use in the form of mostly in high pressure homogenizers, ultrasound, that sort of thing. But very prevalent in Russia too, by the way. Really just starting to catch on in the United States. But to give you an idea of how prevalent it is, when I did the patent search, when I generated my patents, originally starting back in the early 90s, you might see a dozen citations of other prior art, but now you might see more like 800 citations instead of 8. So, I mean, it's really taking off. It's kind of in its golden age right now, in terms of being able to process materials like that. Very difficult to make nanometer-sized particles.
Wow, so this is something that is completely prevalent in our society and has been under our noses the entire time. It's used to make all our pharmaceuticals, our paint, ceramics, food, beverages, oil products, etc. And you've now taken it to the next level as far as transmutation, also energy synthesis as well, correct? You managed to
Yeah,
achieve some of that.
yeah, absolutely. And in fact, I think we need to just to jump back to the fusion part of this thing because this is important. And 1 second here, I'm going to show you another image. Now, this is the temperature of that reactor that was shown earlier. There was a foot-long PVC pipe. It's kind of shown right here. So you've got cavitating flow going into the tube, and these little jets are forming crystallized jets that are zinging along the lengths of that aluminum core. And I had this thing lined with thermocouples, and this is what you're seeing for temperature data. So each one of these colors is an individual thermocouple. So you're seeing the input here, T3, that's the green trace, and then the output is the blue, and then green is, or sorry, red is actually in the center. What we saw was an instantaneous 32-degree Fahrenheit jump the moment I hit the switch on this thing, that the water was coming out 32 degrees warmer than it left the pump. So going from this side of the pump, or sorry, from this side of the chamber of the reactor to that side, you see a 32-degree average temperature rise. And some of these spikes, this is the input right here, this is the inlet temperature, going up to the maximum, you're seeing as much as a 50-degree Fahrenheit jump in some of these things. And if you look, most of these spikes are very narrow and very well defined. You know, it's not smeared out like an average rise. It's not sinusoidal. It's very abrupt. Now that's indicative of a lot of energy being released all at once, aka a small supernova explosion. All right. So the reason that you're seeing these spikes, each one of these created an individual pit in that plate. In fact, if you look at the temperature traces on the right here now, it's shut off, and yet it's still maintaining a high temperature inside the core, even after we shut this thing off from radioactive decay. So
Wow.
now, so I mean, this thing was very powerful. In fact, I'll just flip back. So this is the experiment we did in Washington, D.C. at the Navy. So we were invited by the Naval Research Laboratory to do an experiment. And so here's the core that we used. If you look closely along the edge of this thing, I'll blow it up some more.
Just to give people an idea, the reactor you're using is just a little PVC pipe you can buy in Home Depot for $5, right?
Yeah, this is it right here. I mean, there's the pump, there's the PVC pipe right there for the reactor, and then the outlet of this thing. And down here, you know, you have an inlet that is being fed from a reservoir that I actually put below the level of the inlet of the pump to help force it to cavitate. But the radiation that this thing releases is dangerous, so I don't recommend anybody attempt this at home, because if you look at this close-up right here, this is actually the clear PVC pipe you can see above. I'm getting some pictures now.
Yeah, I'm sorry. Someone just... Great. Someone just muted. Continue,
Okay.
I
please.
got him. I was able to. Somebody joined the channel. I was able to mute him.
Yeah,
All
by
right,
the way,
so, sorry, go ahead.
you can set it to auto-mute people when they join. I'm sorry. Continue, Mark.
Okay, so if you look, you see the image of that drill plate is now burned from the radiation right into the clear PVC. This is a permanent image in the plastic now. And you can see like three-dimensional aspects. You can tell that, you know, it's orbiting into individual holes. Each one of these holes is being orbited by a crystal. And you can see the lines running down the length of this thing. That's lit where a trench passed by right there. See, so any place where the crystal passes by, whether it's circling a hole or running down the columns tangent or even across the circles, you know, it's giving off radiation, and you see a trace burned permanently into the plastic. So there's proof that this thing was releasing radiation. And you look at the metal itself, you know, there's the image of the circular holes right there, burned right into the solid part of the metal from underneath by the neutron flux.
So
Because this thing was really...
I'm sorry, talking about proof that this thing is giving off radiation, you and Sergey, your partner, were actually radiation poisoned during this experiment, correct?
Yeah, in a very severe sort of way. 24 hours after the experiment, first it hit Serge, because we're both sitting very close to the experiment and had no idea that it was giving off radiation. And so he ended up having vomiting, nausea, diarrhea, the whole bit, and we were both sneezing nonstop, because 36 hours later, I was sick just like he was, the same way. And it was really bad. I mean, we spent time in and out of the hospital. They had our blood tested to prove that we had radiation exposure, and they saw chromosome damage that wasn't there before. And so, yeah, we were very weak. You know, I could barely stand up a year afterwards, and even now my whole right side is very, very weak and very sore, atrophied muscles. Serge has a hard time getting around still. I mean, it really messed us up. I mean, the first year we had no control over our body temperatures. So we're going back and forth between hypothermia and fever, both of us, 94 up to 102 degrees back and forth over the course of minutes.
So you certainly pay your dues to earn this knowledge, it sounds like.
Yeah, it was a pretty tough thing to go through. I wouldn't wish it on my worst enemy. I mean, radiation sickness is horrible. I mean, I thought 30 days after I was hit that I was going to die, and I turned to my wife and I said, "You might as well start making out my will."
So people should respect this entire process. This humble little water bubble
Well,
is,
check this out. See this curve that we're looking at? Now,
yes.
down below all this other data, these are a bunch of other experiments that are superimposed, but these are counts per minute. That's the numbers that are going up on the screen. All right. And so 20 counts per minute, that's background. That's way down here. So these are running about anywhere from 20 to 50% above background. Nothing to write home to mom about, right? Well, one day I ran an experiment with that same configuration without the core. All right. No core inside this thing, just a flow restriction. Fired cavitation bubbles into the core of the thing. And it released so much radiation that 2.5 hours after, sorry, 2.5 hours after the experiment was over, this is what I captured on the radioactive decay, that now the PVC suddenly is 20 to 25 times above the background level. And this extrapolated curve back here, that's where it was back during the experiment. And it only ran for 5 minutes. And if you see this exponential curve, every 56 minutes, the intensity level is dropping in half. And so that means that it has a 56-minute half-life to the radioactive decay. You can see it. All right. And so it turns out that that's the radioactive half-life of 39 chlorine, because 35 and 37 chlorine absorb neutrons and they become 39, which is radioactive. And you're seeing the radioactive decay of that radioactive PVC. The chlorine in the PVC is hot, and it goes down to background level after about maybe 6 or 7 hours, right? But there it is. I captured it on a data logger. And so during the experiment, that particular configuration was probably running on the order of 50 times above the background level. So this is not subtle. I mean, that's putting out a lot of radiation. And in fact, you can see the radioactive tracks here that are left in the plastic. And these dishes happen to be in the desk that the experiment was sitting on. So the prompt radiation from the experiment going through the desk created these tracks. And you can actually see some close-ups of them. They're very bizarre. But, oops, sorry. One that I really want to point out is highly illuminating, is this one right here. So what you're seeing is a combination. There's fission right here, because there's a nucleus that's split. And you can see all the tracks that are spreading out. In fact, they're doubles, so they're deuterons. That's an oxygen nucleus right there that's split. And over here, this is fusion because you see a plume, so it's exothermic. It's giving off energy, see? Whereas the fission of a low atomic weight element doesn't release heat. It absorbs energy. It's endothermic. So, you happen to see this. These are right in this plastic dish that was below the experiments. That's what the prompt radiation did to the plastic. Because plastic, it turns out, is really dynamite at seeing nuclear tracks, because now if you look here, this is actually transmuted material that came out of the experiment. I put in small polystyrene dishes. And these dishes formed an opaque ring on the inside, that a close-up of it on the right-hand side here that you see, those are nuclear tracks. It turned the plastic opaque from the radiation, from the transmuted material, which is that picture right here. That's the actual real color of the stuff. It looked like Alice in Wonderland. Every color in the rainbow is in there, all different geometries. And so the transmuted material, you see the chips on the inside here. I mean, these things are millimeters across, but they're radioactive and they're cooking the dish. And you look at the tracks that are forming here. Now this upper one right here that you can see in the upper left-hand corner, that's a gamma ray track. This is a well-known behavior right here. See this long arc that forms right here? That's a positron, and then its matching electron is going in the opposite side. That's what they call a virtual pair. Every pair like that takes a 1 million electron volts to produce. So if you add all these things up, if you add a long chain, then you can tell that it would be produced from a heavy element. So this is indicative of a fairly heavy element undergoing fission and then giving off gamma rays. So from radioactive decay of these things. Like this V that you see on the right-hand side, same idea. Positron track is always longer than the electron track, so it forms like a offset V like that. You can also see all these other spiraling tracks that are present, and so this is inside the plastic. On top of the plastic, I mean, you look at these radiation tracks that are forming up here, straight line tracks, so here's these rusty particles that are spewing high energy particles. The magnetic field is dragging the iron particles along with it. So, I mean, you can see this is happening in the dish. I mean, it's happening all over the place. These are two different areas inside the dish. So you could actually see that happening right in front of your eyes. I watched it under the microscope, and you can see it spewing material. So it was hot as the dickens. I mean, there really isn't much arguing that this stuff was radioactive, and very much so.
Wow, so it actually scarred some plastic that was inside a desk a foot away from the experiment?
Well, the radiation went through the metal top of the desk and through the wooden top and then into the drawer and then caused nuclear tracks to form in the plastic inside the desk. So we're talking some serious radiation levels were produced by this thing. I mean, the neutron flux, probably within 5 or 6 feet of this object was pretty dangerous. And that's what ended up zapping us. Not only did we absorb neutrons, but we also breathed transmuted gases. In fact, here's where the transmutation is occurring. Like, if you look at these pictures, I'm showing the holes inside the drilled out plate. And you can see the crystal is bouncing along, see the track that it formed? And sometimes it'll orbit the inside of the holes, and look at that, it fills it with transmuted material. And these coiled up ribbons here came out of the holes. So I removed those and analyzed them, and that's where all the information from both scanning electron microscope data comes from, right? So we're zapping these things with X-rays, and we can actually see what elements are present. And some of these chips, like look at this one, is green. See how it's got bubbles on the surface? Might be kind of hard to see. Let me see.
Yeah, we see it. What are they made of?
Yeah, 1 second. Well, this white one here is mostly calcium carbonate, as it turns out. But so that's why it's white, because the calcium is making it white. The green one here is actually predominantly copper and zinc with some lead thrown in there. So the copper oxides are making it green. But these things are loaded with elements that just don't belong there, and isotopes. Because I went back and measured not only the elements, but how many radioactive species there were. And I found like, I don't know, probably 40 or 50 isotopes that are known to be radioactive. And in fact, you can see the radioactive gases kind of inflated some of these rust particles. See, like, the edge of it is all fused, so it inflated like a little balloon. So these are some of the pictures, and so you can see the bubbles that were present here inside that chip. They're emitting gases, so there's like little voids where these particles are off-gassing radioactive gases while they're actually emitting. All right, so here's a nice picture right here. But I mean, look at the color of this stuff. It's just wild, This is what came out of this thing. All these crazy colors: purple, green, orange. And in fact, I ended up labeling these things just basically by their color: green chip, orange chip, blue chip, because I had no other way to really classify what I was looking at. And so if you look at the analysis that I do downstream here, and you just pop down, like, here's an example. That blue chip that you were looking at that had the bubbles in it, there's some very nasty stuff present here. Let me show you. All right, so this is what they call a scanning electron microscope EDAX, that's X-ray dispersive analysis. And these are the elements that were present in that blue chip. You see this one right here? That's polonium, PO. That stuff is super nasty. And the only way it's produced is right straight out of an atomic reactor. So this stuff does not exist. This PO210 right here does not exist in nature because it decays out, has a half-life of around 270 days. So, it's gone. There's none of this is present in nature. So you couldn't argue that this was contamination. It's far too great in terms of its the level that was present. And you see all sorts of other interesting elements too, like on top, Br, that's bromine. Well, you don't find that in nature in too many places either. So the overall result of this thing, we looked at it with different ways. There's the XPS analysis, and in fact, let me back up here 1 second. Yeah, right here. All right, so here's the diamond that formed right here. Here's a close-up scanning electron microscope. Some areas were like glaze, and you can see that, I'll expand that too. But I mean, look at that riot right there. I mean, this stuff here is actually what came out of the trenches. That's why it formed all these different ribbons. So every time it carved a trench, it left a diamond coating on the bottom of the trench, and this formed a mass of diamond fiber. And in some places, you know, it was hotter than the melting temperature of the diamond. Look at the holes here where the outgases came out. So this stuff is loaded with radioactive gas that's coming out of the molten diamond as it forms. So it's not a subtle event. I mean, it's producing a tremendous amount of energy. It's melting the substrate to the aluminum plate. You know, here's some of the SEM-EDAX data. What do we see? It's mostly carbon, right? Just like a diamond would be. Basically 100% carbon with a smattering of other elements. You know, so yeah, so these are some of the typical ones. But you can see like lots of sodium. It was producing a lot of the lower atomic weight elements and less of the heavier ones. Okay? And in fact, I'm going to jump right ahead now to another curve, which I think is really going to enlighten things.
So
Now,
just
these
so
are some.
people understand, this is absolute definitive proof of transmutation. This EDAX test is one of the most thorough tests you can perform, correct?
Well, actually, the data that you're looking at now, see, this is called laser ablative mass spectrometry. So this is mass spec. This is what the FBI uses when they sit there and they do forensic analysis and they want to identify what was present. Because if you look at these numbers here, it's identifying not just the elements, but it's identifying versions of the elements that are isotopes. For instance, like see, GE, that's gallium 72 and 73, so it's picking out different isotopes of that, 66 zinc and 67 zinc. So I'm able to take isotope ratios, you know, of all the various elements, and as you look at the list of this thing, now look how far up it goes on the list. You know, like these are each double column like this is just one chip, you know, transmuted material that was present. So, sorry. See, so orange chip, blue chip. Other ways, like some of it looked like those white circular pieces. And if you look like, for instance, this white chip, that was that white curly Q that you saw earlier. Look what's present in this stuff. That's californium down there. See, there's counts for berkelium, californium, cerium. Right here, Pu-239. That's plutonium. You know, so there's what, 6 transuranic elements present, you know, in different ratios depending on the chip. You know, some of these things had.
Just so people understand, these are among the heaviest, densest elements on the periodic table known to man, correct?
Yeah, I mean, you're almost up to like californium, I think is element 98 or 99, so it's way up on the periodic table. So basically, I detected around 100 elements.
So it's fair to say with the dense crystal that's compacting, the more denser materials and elements are going to appear first?
Well, if you start with, say, you don't use aluminum and use steel instead or copper.
Right, at impact point.
Yeah, the impact point. So the seed material that you start with, the heavier it is, the more you see of the heavier material being produced. And in fact, you can kind of see that here because some of the, see like the rust particles? See it says rust?
Have you done any experiments with palladium?
Well, actually,
Cavitation effects?
you know, it's funny is this actually produced palladium.
I was going to say it probably produced palladium, which is extremely another unique material out there.
Well, yeah, palladium, let me see, is right here. Well, I'm going to jump ahead to the cursor. This will make it much easier to see. All right, so here's
this is the monatomic structure of it, unriddled in any way, shape, or form. It's the purest form of it.
well, like here's all that data, you know, that
Yep.
I've collected from all the SEM-EDAX, and later on I'll show you mass spec. All right, and the yellow curve that you see here, these are natural distributions that are seen in the sun. And if
Okay.
you look, they tend to zigzag like this.
Mm-hmm.
This is something that's called the odd-even rule of astronomers, that it produces more of the even-numbered elements and less of the heavy ones. And so look at all the stuff that I detected. Lots of carbon, you know, less and less as you get further up the periodic table. Well, this is the same distribution that you see being produced by a supernova. right?
And this distribution is probably reflected in some universal equation, whether it be the Fibonacci sequence or some other mathematical equation we see commonly recurring in natural nature.
Yeah, I mean, it's forming on a shock wave, in this case, the one that surrounds the crystal, and it's
Yep.
forming on a shock wave surrounding a supernova. So it's shock wave nuclear synthesis.
Whether it's a shock wave at a micro level, meaning a little piece of material, or a shock wave at a supernova level, it's still cavitation.
Well, no, it's not so much that it's cavitation, it's a high energy shock that's traveling at up to
The
half the
shock
speed of
wave.
light.
Okay. It's
Yeah,
the
because it's
shock wave. Yes.
like a supernova shock wave, just to put a number on it, will travel between a tenth the speed of light and half the speed of light. So a tenth the speed of light is synthesizing maybe calcium, and the half the speed of light is californium, right?
So as it spreads out its spectrum, it's as the energy spreads out into its 7 colors and everything that's in between it, all of those elements in between come out of the fractality.
Well, it's not even that complicated. The faster that crystal goes, and as it plows the material in front of it, the pressure just keeps climbing.
Climbing and
And, as,
climbing and climbing.
and at an individual pressure, you see an individual isotope or an individual element. See, so if you're able to hold the speed steady at some high speed, you would form just one element, like gold.
If you
Right.
were
So
able to
now,
hold the speed of the re-entrant jet.
yeah, if I was able to slow down on the LeClaire effect so this thing doesn't try to go to the speed of light, and I hold it, say, at half the speed of light, it would be producing all the transuranics in high quantities.
Right, and
So
that's
the,
where you can build a scale to manifest whatever material you want out of the transmutating factor.
Yeah, if you can control the terminal, if you can get this thing to travel at a terminal speed like that, just like when you drop, like out of an airplane and you're only going 120 miles an hour because of the drag.
so
Same idea.
it sounds like there's two factors. There's the speed of the re-entrant jet, and then there's the material that you're using as for the metal plate. Instead of metal, you can use carbon, copper, etc. Those two factors will control what elements you're getting to appear.
Yeah, I've already seen it happen. I mean, when I did some of the iron that came out of the pump traveled through that core, because so these rust particles were being irradiated and hit by the jets, and the result is that those are some of the hottest particles that came out. Because it's going up into the high end of the periodic table, which is really radioactive, right? In fact, let's take a look at these curves here. I want to point something out to you. Like, if I look at this top curve here, this is a weight concentration, okay? Now, when they did the analysis, they didn't look at every isotope that might have been present, just like a select set that they typically do at the analysis place that did it, right?
Can you make that picture bigger? It's really tough to see your mouse when you're showing it.
Yeah,
You just got a white on white background, and I know I've seen some of the comments here, and it just makes it a lot easier when you make it bigger and move your mouse a little fast so people can see where it's at.
right. Okay, I think that'll help. All right, so now, okay, so here's two different curves. Now, this is what we actually, this is what I actually measured
Okay.
on the top curve. And then what I did is I decided to include an equal amount of the other isotopes that weren't actually measured but ought to be there. Because they didn't, like I say, these guys measured 78 different isotopes. They didn't measure like all 400 or 500 that there are. So I decided to include those as I knew the stable ones were probably being produced in the same amounts. Because if you look at this curve as it goes across the periodic table from left to right, after you get down into this region on the right-hand side of it, it's pretty much level. So you're producing roughly equal amounts of every single isotope, and it's just dropping exponentially as it goes towards the heavy end of the periodic table, right? So by including some of those unseen isotopes, just to get a better estimate of what probably is there if I'd measured every single isotope, that's what this curve on the bottom is showing. Now all of a sudden you see the sawtooth form is really jumped out at it, and it's hard to see on the top one. Right, there's that sawtooth behavior. Well, that's only seen in supernovas. That's stellar nucleosynthesis right there, because it's favoring, it keeps tacking a helium nucleus on each atom that's produced. And each one of these
Ironically,
peaks,
you see that same sawtooth formation when they turn the harp and the scalar weapons on. You can see it in your local news reporters when they're trying to figure out why the weather's changing. You can see that pattern. It's really amusing because it only shows up when they turn it on.
well, let me make one final point here, because this is the real clincher. If you look at this blue curve on the top, Okay, that's actually the average concentration of these elements in the Earth's crust, and it matches the top part of this, but not the bottom. The purple curve on the bottom is meteorites. So if you look, this is 100 times the concentration of my transmuted material than you see in a meteorite, but it happens to match the exact average concentration of these elements averaged all over the surface of the Earth, and yet no material on Earth has every element in it. But these did, and they matched the average distribution across the Earth. You know what this represents? This is evidence that cavitation and transmutation produce most of the material, not the meteorites, because it's 100 times the concentration, right? So how do you concentrate meteorites, which are down here, into a concentration that's 100 times greater like that? So the point is that this is evidence that cavitation probably produced on the order of 99% of the material, and the other 1% came from meteorites, which are transporting supernova transmuted material, which is where everybody seems to think it comes from. Well, supernova contribution would be on those meteorites like you see here, but they're 1/100th the concentration of the cavitation transmuted material. You follow what I'm saying? So in other
Absolutely, and
words,
that leads into my one question here about the graph you have going. That last big spike before the sawtooth gets really familiar. Where is that at? It's hard to read on that graph.
well, I'm glad you pointed that out because that's 10. I happen to know this graph by heart, actually. So this is evidence of the radioactive decay of the unknowns, which are way over here. Because if you
Hmm.
take element number 50, see it's number 50 right here, you multiply that by 2, that's element number 100 split right in half. So in other words, the fact that you see so much material right here at 10, this is direct evidence of the daughter elements produced from the heaviest elements there are being split in half. And the other big peaks are the same. These are all radioactive decay peaks. In fact, let me show you. This is an actual curve of the radioactive decay of various elements. Like, for instance, uranium produces 2 spikes. All right. So you get a distribution of daughter elements here and another one on the higher end of the table. And as you go further up the periodic table, like the light blue, that's californium. So you see 2 spikes there. But once you go past californium up into einsteinium, lawrencium, it forms a single spike of tin right there. So that single spike of tin that you're seeing is the same that you're seeing in the data right directly above it. So there you go. I mean, these spikes right here correspond to the ones below here, which are uranium fission. So in other words, like this here is barium. Okay, so there's the barium spike, and over here, what do you get? Uh, cesium and strontium. These are all known fallout materials. So you're seeing, reinforcement in these spikes is because of the radioactive decay that's being produced, and it's producing all the same elemental distributions that you would see inside of a nuclear explosion or in
Yeah,
stellar nucleosynthesis.
that's absolutely impressive. This leads me into one more angle of questioning. Um, I'm gonna just think of right way to describing it. Um, the spike, that last spike, it's fair to say that's when the most amount of transmutation is going on before the sawtooth takes over.
Well, what's really interesting here is that the implication is that if you look how high the spike is, I mean, there's, almost 10,000 times more tin than the other elements surrounding it, right?
Right.
So this implies that most of the material was bulldozed right to the very top of the periodic table and then fissioned out immediately.
Exactly. It's separation of densities.
Well, I mean, it's going to the point where it generates so much local radioactivity that anything that's been synthesized is suddenly split apart. It's what they call fusion fission cycling. They
Mhm.
always happen hand in hand. One feeds the other.
So does the background Schumann resonance of the Earth determine this if how much transmutation is going on? Because I mean, it is part of the reality environment we work in.
No, I mean, it's all determined by how fast that crystal is going and
It's
the
all by
LeClaire
the
effect is.
speed of the crystal. That's exactly
Yeah,
what I wanted to know. It's all by the control by the speed of the crystal.
think of the crystal as bulldozing the material in front of it, and in front of the plow of the bulldozer, that's where the fusion's happening, and this is the result right here. This is what you're seeing.
So,
So I mean,
Mark, I have a heretical question to ask you.
fire away.
have you measured the the amount of like water and just total material when you put it in and then when you got it out? Like where are these elements coming from? Is the water being transmuted into all these elements, or is it coming from somewhere else?
Now, I'm glad you raised that question. In fact, I've concluded that it's roughly half and half. That about half of the transmuted material is coming from the water, and then the other half from the substrate.
The substrate
Because
meaning the aluminum plate or the steel plate.
hmm in fact, one of the signs of this thing. In fact, I'm glad you said that because I want to jump ahead to another curve here that's really going to bring it out. Here we go. So what I did is I noticed that the bulk of the material, the transmuted chips, were made out of carbon and oxygen. See the blue curve? Okay, so it turns out that 80% of the composition was carbon or oxygen, and then the other 15 or 20% was this other smattering of all the other elements. Okay, so this is typical of, think of a white dwarf. A white dwarf is made out of carbon and oxygen, and in many instances, guess what? It's a diamond, just like the diamond that we saw. So that was the first step along the way of stellar nucleosynthesis. Because in a star, what happens is when you start producing carbon, at that point, this thing is undergoing a supernova explosion, all right? Because you can't burn carbon in an ordinary star, all right? And so only in the heaviest stars with core collapse of like 8 solar mass stars, really big ones. But I noticed there was a difference here in the transmutation. Like if you look at this one curve right here, this peak, that's actually chlorine. There was more chlorine present than you would have seen in stellar nucleosynthesis. And the reason why is the sun has hydrogen in it, but doesn't have a lot of oxygen present. All right, and so by having oxygen present, when you fuse oxygen together along with the proton, you get chlorine. All right, and I think that this is evidence of where the chlorine came from in the ocean. That the salt in the ocean came from the sodium, which is one of the other curves here. I believe it's the red curve. All right, that the chlorine and the sodium are being produced by the transmutation, and the salt in the ocean came from cavitation transmutation. All right. Now, to look at this curve, each one of these, like say I take one point here, like this one right here. So I've got oxygen at this level, I've got carbon at maybe 80%, but I'm seeing maybe 5 or 10% of, let me jump ahead, we can see the scale. All right, so I'm seeing, up to 15, 20% of some of these other elements. I don't see any of the heavy elements being produced in this chart until I burn a lot of carbon. In other words, the reason that I charted this thing this way, I put the x-axis being the carbon percentage. So for a particular particle, if it was made out of half carbon, it would fall right here. All right. And so at that point, by the time you burn half the carbon in the thing, then you've produced a lot of oxygen. That's the first step along the way. The next thing above carbon is oxygen and alpha nucleosynthesis. You tack a helium nucleus on the carbon, and you go from 12 right to 16 on the atomic table, say. So this is what's happening, is that it's as the carbon disappears, the oxygen is being created. As the oxygen disappears, the other elements are being created, and vice versa, all the way up. Periodic table is that elements are being both created and consumed by subsequent reactions that drive it even further up the table. So by the time you burn maybe half the carbon, now you're getting into producing iron, you're producing tin, you're producing zinc. You don't see any of that on the right-hand side of this curve. So this material came from 12 different experiments done over the course of 3 years, all different types of configurations, but yet it painted exactly the same picture. This thing is following the exact same behavior as the supernova does in terms of the elemental distributions relative to the carbon and oxygen. To a person who knows astrophysics and knows stellar nucleosynthesis, this curve should be very clear that this is evidence of supernova origin of this transmuted material. This in my eyes is proof of that.
Wow. Well, he certainly gave us a master class on transmutation there. Is there anything else you want to say about the transmutation aspect? Because I kind of want to take it back to the theory
Yeah,
of life.
let's just, sure, I want to hit, well, this all ties together now. Remember, I measured isotopes, and I took ratios of the ones that were measured, and I compared them to what's known in solar abundances. So like the yellow is like the sun. And so you can see that some of these elements are up to 10,000 times different in their ratios than you see in the sun. So that implies that these things came right straight out of the oven. The only way you see such departures like this is from coming right straight out of a nuclear reaction or radioactive decay. So I mean, these isotope ratios prove that the stuff has a very hot nuclear origin. Okay, so anyway, yeah, we can get back to some questions here.
Yeah, you've got quite a few questions in the chat. People want to know. So question number one, I think this one is pretty simple, by Colin Schmidt. And when those bubbles collapse to a toroidal form, tiny scale fusion occurs, correct?
Well, you end up getting both some fusion inside the bubble, but really the bulk of it is occurring right in front of the reentrant jet itself. In fact, if you look at sonofusion, this is just ultrasound producing a cavitation bubble inside of a resonant chamber. You don't get the same kind of pressure at the final point of collapse of the bubble that you get from the impact of the jet. In fact, what I'm going to show you next is a curve that really illustrates that, because I actually solved the cavitation erosion problem along the way too. This is another major part of the discovery, is that I can tell you exactly what's going to happen with cavitation erosion. Okay, here we go. All right, so when we impact into a material, it turns out that if the material is very soft, then the impact will behave classically. This will follow like a classical impact equation for a material where you use the volume instead of the area for shear. And that's a well-known equation. They just typically call it the impact equation. But it turns out this red zone here is the result of very high van der Waals repulsion, because this is hitting so hard that the atoms are repelling each other. And the van der Waals repulsion creates a pressure right at the point of impact, which is so high that it's capable of igniting fusion in the hardest materials. Even without the LeClaire effect, just the straight impact of a cavitation jet is right on the hairy edge of being thermodynamically capable of producing that kind of pressure. In fact, you can see from this curve down here, the zone is very thin. It's on the order of, depending on the hardness of the material here, it can be up to like maybe 80 nanometers thick, but it's not very thick. It's only maybe a few hundred atoms wide on the red zone. But for the hardest materials, up to 50 or 60% of the energy in blowing the material out of the hole actually came from van der Waals repulsion. Okay? And so in this equation, by the way, has been validated against 22 different materials, so I know it's extremely accurate. And if we look at the pressure that's being calculated in that van der Waals zone, it's a hell of a lot higher than, using Bernoulli's equation, which says, you might get 200,000-300,000 psi. This is saying you're achieving pressures that are on the order of, now this is in pascals, 1 times 10 to the 9th. That's way down the bottom down here. That's the pressure inside the center of the sun. It's 1 billion pascals, so 10 to the 9th. This is saying for the hardest materials, you're achieving momentary pressures in that van der Waals repulsion zone that are 10,000 times higher than the pressure inside the sun. All right, so I mean, you have the ability to ignite fusion from your entrant jet impact, and even the final collapse of the bubble will achieve high pressures, but nothing compared to what you're seeing here because of this van der Waals repulsion. This is why my way of being able to harness cavitation is producing intense fusion versus the other techniques like ultrasound. They just get a smattering of it, and they get a few neutrons, but they don't get the full-blown reaction like I get. And that's because reentrant jet impact is where it's at. The other ways are just not the way to go.
So what you just said is that through plain old run-of-the-mill cavitation, you can get near fusion level effects?
Yeah, if you take the fact that this is hitting a few thousand degrees C because you're melting diamonds on impact, right? You combine 3,000 or 4,000 degrees C with these kinds of pressures, and you've got the thermodynamic equation of state for fusion for like deuterium-tritium fusion. It's there.
Okay, so make this clear. Explain this to me like I'm a 6-year-old. By plain old cavitation, we can get this through what? Through just boiling or putting a propeller in there and heating something? I mean,
yeah,
what?
Just like I showed you before, where it forms the bubble next to an object and it creates that jet. When that jet strikes an object and makes a pit, that pit will have a pressure zone right at the point of impact that's just high enough to ignite momentary fusion.
Okay, so so this could potentially be happening when I hate to say it, when I'm like boiling eggs or something. I mean, I just give me an idea of.
Yeah, let me point that out, because if you look at boiling. Boiling at room temperature is not the same as boiling at 212 degrees. So in other words, like if you get a teapot and it's rocking around on the stove, those are cavitation bubbles, but they're so full of vapor that it inhibits the collapse of the bubble. Acts like a
Ah,
shock absorber, say. So the result is you don't get those kinds of high pressures with vapor-laden bubbles, only ones that are nearly empty. Right.
okay.
So if
Okay.
I take a laser and I form a steam bubble instead of just turning it on the stove, right, then I end up with a cavity that's only contains, you know, just a smattering of molecules inside the thing. It's almost empty. And the result is when it begins to compress that vapor, it superheats it, and it actually goes beyond the pressure that it formed at, and you go all the way up to like crazy pressures inside the final point of collapse, right? So,
Okay.
so the result is, even though cavitation collapse is intense, reentrant jet impact is 10,000 times more intense in terms of pressure.
Okay, well, that's a revelation. You just
I,
said
I
so.
just want to jump in here real quick. Our audience
Sure.
is rapidly growing here, so I want to remind people if you have questions specific about the LeClaire effect, you can go to newearthnation.org onto the main page there. I'm sorry, on the link page there, there's a Facebook link for questions. You can go to Aether Force. We are monitoring all of these, as well as in the chat links over here. You can do it, so we are monitoring. Put your questions in capital letters, and if we have extra time, Mark, if you'd like to go over to take more questions, we're willing to do
Sure.
it. We built up a pretty good audience over here after this presentation. So people get out there and share. It is only through the people sharing and people coming together like TechZ, Mark, Noah, and everyone else that's come to join us in the room here. It's when we share all of this information that alchemy and the LeClaire effect are one and the same. Why? We have been searching for transmutation. He has got the proof of transmutation, their transmutation of the fusion expressions that he's going through. It's all there. We just need to apply this technology to our consciousness and say, hey, we can create. We do not need Ford Escorts that rot in 2 years.
In fact, I'd like to hear Noah's input on this because she actually got to hold the reactor in her hands back in Vermont, saw the transmuted material, saw the presentation, saw the reaction of the audience. So why don't you give us your 2 cents, Noah?
Could you unmute Noah, please?
Yeah,
Oh, yeah.
I think I just got it.
We can hear you.
Thanks. Yeah, great. Mark, that presentation you delivered in Vermont was thrilling, as is this one today. So thanks
Thank
for
you.
sharing. You have so much material. It's always nice to see it. I have so many questions that I'm obviously not going to be able to get to all of them, and I don't want to take anyone else's time. So I'll focus on a few of them. For my curiosity, what's the maximum amount of distance between the collapsing bubble and an object for the reentrant jet to occur? How far
It
did I
has
need to be?
it has to be within 6 fully expanded bubble diameters. So in other words, if I create a steam bubble that's a millimeter across, if I'm more than 6 millimeters away from the surface, the bubble won't form a jet and it'll just collapse to a dot. And in fact, if it's 3 diameters away, it'll form the strongest reentrant jet. And when I do machining with it, that's typically where I'll form the bubbles 3 bubble diameters away from the surface. So it has to be close enough that it inhibits the collapse of the bubble, and 6 diameters is the number.
You know why that is?
Well, because the suction effect is the bubble begins to pull away from the plate. Think of like peeling a wet card off of a table, like if you're playing cards. It creates a suction effect. It doesn't begin to pull on the bubble like that if it's a long ways from like say the plate that you're collapsing that bubble next to. If you're really far away from it, it doesn't even sense the presence of the plate. If it's close to it, one side of the bubble will stick to the plate, and the other side won't. It'll turn itself inside out. That's basically what's happening.
Okay. Um, I was wondering if you could touch on sonoluminescence, which is one of my favorite phenomena, and how it might relate to cavitation.
Yeah, sonoluminescence is actually almost a misnomer. I mean, it's ordinary cavitation, but you're seeing the flash of the plasma inside the bubble. And that's enhanced if you happen to have oxygen or other noble gases that might be present will light it up like a neon sign. So the result is it'll give off a very powerful visible flash that you can see with your eye. But there's really not much that's different from that in other cavitation bubbles. They give off light too, but it's in a spectrum that ranges from visible through ultraviolet and right up into soft X-rays. And it has a very distinct signature. They call that Bremsstrahlung radiation. So cavitation bubbles have been known for decades to give off Bremsstrahlung. And so this is a well-known phenomenon. So sonoluminescence, it just doesn't jump out at me as being anything special. It's just, another peculiar visible version of cavitation phenomenon, but it's just part of the same collection of phenomena.
Okay. The crystals that form with the reentrant jet, what's the lifetime of the crystal? Does it exist if it doesn't strike an object or another bubble?
Yeah, if this thing was like fired off into outer space and it was in a vacuum, it would survive forever. It's metastable.
Okay.
So if it's close to an object, it'll be attracted to it and it'll embed itself and then it'll revert to the water. But if that doesn't happen, then it can last a long time. In fact, I built a version of this thing that I call my squirt gun. I actually launched these jets through the air, out of the water, and I've launched them across the room like up to 7 meters away. So these things were persisting on the order of maybe a millisecond, instead of nanoseconds or microseconds. The crystal structure survived going through the air, and when it hit the paper target, you could see the crystal impact of facets into the paper, and a dot of water reverted back to water. Pretty amazing, huh?
Yeah.
I love my squirt gun.
If I could just ask one more question, this one's a little bit more general. The Schumann resonance was touched on, and I'm wondering about magnetic fields in general. Have you tried any experiments in the presence of a magnetic field, considering that during the time of? Oh, sorry, go for it.
Well, what I've done is mostly steered it with electrostatic fields versus magnetic, but what it would do is a magnetic field would cause it to spiral because it's a moving charge. So it'll spiral around each of the magnetic field lines. So that, that's another way to be able to control this thing if you wanted to get it to go where you want it to go.
Okay.
So the answer is, yeah, it's very powerfully affected by magnetic fields. And in fact, it tends to generate a very powerful magnetic field. A lot of these transmuted materials bear incredibly strong magnetic signatures. I mean, even material that's not supposed to be magnetizable, like quartz, is magnetic in a lot of instances in these things.
That has such massive ramifications, magnetic quartz. Massive ramifications. My question about the spiral and the sonomatic effects you were talking about, this can be an off-the-wall question, but it comes down to the flashes that people see when UFOs take off, instantaneous flash. It sounds exactly like that science, that they are transmuting the energies of the area and going from one part to another, and they're bulldozing through time-space.
Well, I think the UFO propulsion and the LeClaire effect are one and the same.
Absolutely. And I think the burst of light is that sonomatic effect you're talking about.
Yeah, like these globes of fire that you see typical of a lot of UFOs. You're seeing heavy ionization of the air. That's why you're seeing the fire, right? So they're causing a very powerful electrostatic field surrounding the hull of the UFO. And then the LeClaire effect kicks in because all you have to do is be able to steer this thing by concentrating the shock wave on one side. They're probably doing it through some sort of artificial means, similar to like what Hutchison was doing, where he's creating a zone of very dense electron cloud surrounding like objects, hits it with a Tesla coil that forces the electrons into resonance. And what you see is levitation. So it's causing a reduction in forces surrounding the thing. And I've seen this happen with the LeClaire effect, that all the forces surrounding the crystal were radically reduced by the Heisenberg uncertainty principle to the point where it nearly erased the inertia of the crystal. And I know this because when you calculate going from 0 to half the speed of light in the distance of a millimeter, how does an object survive that kind of astronomical acceleration and not come apart? And yet that serrated edge that you saw on the metal plate was a series of supernova explosions that the crystal survived, one right after the other. So it was like it was insulated from all the forces surrounding it. It was doing right-angle turns at high speeds, and now we see UFOs doing the same thing. That's because it reduced the inertia inside the zone where the crystal was, just like the UFO propulsion does. The result is the pilots aren't torn apart by doing a radical right-hand turn that creates a 10,000 G acceleration on the pilot that would just...
While in an electromagnetic environment.
Yeah.
While in an electromagnetic environment such as a planet.
Yeah, think of hyperspace as being a bubble that you create.
Yep.
and that you're isolated from the outside surrounding physics because the Heisenberg uncertainty principle doesn't allow any of it to pass through that barrier. That's what's happening on the shock wave of this thing. It's causing reduction in drag surrounding the crystal, which allows it to accelerate. It reduces the inertia of the crystal, so it really accelerates like crazy without resistance. And that's how it's getting up to relativistic speeds in such short distances. That's maybe the most important physics part of this, that, in my eyes, is the reduction of inertia through the Heisenberg principle has never been seen before.
Right. And when you have the reductions of inertias and you look at over a very long distance in space, when something's traveling extremely long distance, thousands of light years, you are using that hyperspace bubble to alter time and space and go from one reality bubble, which is Earth, into another reality bubble, which may perceive time differently. And with the LeClaire effect, you can sync at the elemental level of the magnetic frequency of that planet. Boom, right into the reality.
Well, I think the LeClaire effect is going to be the basis behind, honest to God, real warp drive. I mean, this thing's going to create interstellar space travel. I mean, bring it on. I mean, this thing, if you created the
Arch
same
travel
effect.
too.
Sorry?
The arch travel, where they say you go in through the arch and come out the other side in another world, it's the same thing.
Well, in this case, I mean, it's different than a wormhole. That's tough to create based on general relativity. So this gets
Well,
around
you're
that
still
problem.
talking about in theory, creating a crystal that can plow through time-space. When there's a consciousness that can be inside that crystal, because consciousness and crystals go hand in hand, this is the next level of science and spirituality, shaking hands and agreeing that consciousness is a part of quantum energy. And how we begin to research after that is you could look an idea, consciousness can be in a crystal. Well, it's going through all of those incredible effects, like in that example, you have a magnetized crystal, you could have a consciousness attached to it.
Well, just to touch on that, because this raises a really important part of the original life theory, which is, it's one thing to be able to assemble the molecules, but the central question is, what's the guiding principle that's allowing these things to assemble into useful proteins, not be junk DNA? In other words, look at the interaction of the assembly of the crystal coming out of the bubble. There's 20 or 30 different forces that are subtly interacting with each other. And that interaction, which is very chaotic, is really what's generating the genetic code. So, I mean, there's something going on inside there that's allowing it to produce, useful proteins in order to form life. And so, really, the central question here to go forward on the cavitation original life theory is, it's one thing to produce DNA, but it's another thing to produce useful DNA. And in fact, I was going to do my PhD thesis on the cavitation original life theory with Worcester Polytechnic Institute, and they were telling me, that they weren't so much worried about forming DNA and all that. They're more concerned about proteins because those are what really affect your body. And we probably would have done those experiments in a very high containment, like class 3 or class 4 facility at least, just to prevent anything from escaping, shall we say. So I was actually going to try to create life from scratch on my PhD thesis. That never went forward because one of the people who was originally one of the leaders of cold fusion in the Navy, Dave Nagel, actually dropped the ball, and we never ended up receiving any funding and didn't go forward, so I ended up not getting a PhD because we had no money.
Perhaps that was a blessing. You don't want to go into Dr. Frankenstein territory with all the other all the other amazing innovations you're dealing with. So just to summarize for people, the LeClaire effect is essentially an electrostatic phenomenon, not electromagnetic.
Yeah, you're going to have that electrostatic field being set up. That's where the crystal comes in. If it was just a high-speed projectile with no charge, this would never happen. Because what's happening is that, because let's focus on that. I'll go back and show you a close-up here.
Okay, and I just want to point this out. The reason I asked this question is because in the entire quote-unquote alternative energy scene, everyone makes a big fuss about electromagnetism, and they still ignore electrostatics, which I think is more important, and that's really what Tesla and guys like Oleg Jeffimenko, harped on for years. So,
well, in fact, that points out a primary difference between these theories, and let me kind of jump ahead and I'll show you. If you look at what people are saying as far as Pons-Fleischmann cells, they're claiming the fusion is occurring inside the material. I'm saying that it's happening outside, and that the transmutation and the radiation and the fusion are all occurring right at the surface at the point of impact. So they're saying it's happening from the inside out, and I'm complete doubt about that, because you see these pits in the electrodes and they're full of transmuted material. That didn't happen inside the material, it happened from the outside, and it was from the impact of these jets. So I'm saying that the Pons-Fleischmann effect is really just the LeClaire effect from the impact of these reentrant jets, these crystallized reentrant jets. So they're accelerating towards the electrodes, and the electrostatic attraction gives it a little extra oomph, so that it hits hotter than it would if it just came out of the bubble and just slowed down and hit the electrodes. And when you calculate the electrostatic potential energy of these crystals, it can add anywhere from 30 to 70% more energy to the motion of the jet than it had when it came out of the bubble. So just the fact that it's crystallized, you've already picked up this extra electrostatic attraction that will result in excess energy, even without the trench effect or the LeClaire effect kicking in like that. All right, so this is exactly what they see in the Pons-Fleischmann. They see 130 to 170% thermal efficiency. Well, that's because of the acceleration of that charged crystal into the electrode. Okay, so if you look at ultrasound, see you get the bubbles collapsing inside the chamber. There is no jet being formed, but the actual interface itself, I've discovered in a lot of instances, crystallized. So there's a little bit of the LeClaire effect occurring even on the shock front as it accelerates, just like the shock front surrounding the front of the reentrant jet. So it happens to a small degree in ultrasonic collapse and to a large degree in reentrant jet impact.
Wow, so you just dropped a huge bombshell on there. You believe cavitation is a secret to cold fusion. I mean,
yeah, it really is. In fact, think about that result I showed you earlier with the radiation that had no core. So I'm firing cavitation reentrant jets into water, and that produced more radiation than the core did, but less transmutation. There's like a balance that went on. So if you see more radiation, you see less transmutation, because one, sucks up the energy from the other. So how do you argue that it was caused by some sort of electrochemistry when there's no electric current going on? By the way, the distribution of the elements in the electrodes in the Pons-Fleischmann cells ended up being exactly the same distribution that I saw with cavitation, and yet I did it without any palladium, without heavy water, so the common thread, it was cavitation in both instances. I produced 1,000 times the concentration and 1,000 times the thermal output, all right? But bottom line is it was the same mechanism that was at work at both. They just didn't understand they were generating cavitation on the face of the electrodes. They could see a plasma forming right on the electrode underwater. Well, that generates cavitation.
wow. Okay, and for those that don't realize, cold fusion, those experiments happened in water. There were just two electrodes in water. So all this is happening in water. So what Mark is saying is very within the realm of possibility. Correct, Mark?
That's right. In fact, water, heavy water, and also solutions of water like deuterated acetone, that's what Taliarkin did. But the bottom line is you had to have water present in some shape or form, because that generates the crystal. And if it's not happening in water, then it's not going to happen.
Okay, I have a question for Noah, actually. Noah,
Okay.
you've worked with Gerald Pollack and Easy Water, and listening to this mind-blowing presentation by Mark, I'm sure like a million connections are fired in your brain. I would like it if you could share one or two of them with us. I'm in particular curious about the hexagonal structure of the water and any connections you might have noticed there.
Sure. You can hear me, right?
I can hear you.
Fantastic. Yeah, I was just refreshing myself with one of Dr. Pollack's publications, his recent novel or book that came out, The Fourth Phase of Water. And in there he talks about a very similar structure of water. He points out that ice has that crystalline structure and suggests that maybe easy water, this bound form of water that possesses extremely unusual qualities that we don't associate with bulk water, that this is also a similar form, also hexagonal form, essentially, and that it has more of a fluid nature, and that it is able to shear and to break and to lose ions and to reformulate itself, very much in the way that Mark describes these hexagonal crystals that are able to break up and then reconnect so that they turn into larger threads as opposed to just a stable crystal that can't fluctuate around that shape. Does that answer your question?
Well,
That's an awesome connection.
I'd like to add a comment actually is that the
Yeah.
difference between easy water and the crystal is that the crystal has a triangle subunit and easy water has a hexagonal subunit. So the result is you can pack more material into a smaller volume under high pressure
Mhm.
with my version of the crystal. But there's got to be interaction when life is being formed between the easy layer and the crystal itself. The two are interacting with each other because you can't have biological processes, as you know. I mean, without easy water being involved, right? So during the creation of life with the crystal as the template, easy water also came into play. And in fact, it's a whole unexplored chapter that I think maybe someday you'll probably add to.
I hope so.
I think that's where
Um,
the conscious application of our minds as the observer begins to change quantum reality and physics.
that's absolutely arguable.
But you know what's
There's
really interesting? Sorry, no.
no,
Yeah,
go for it.
is that here we have two species of water that no one's ever seen before, easy water and the crystal, and yet they all thought they had water figured out a long time ago, right now?
Yeah, they definitely thought that, and now we realize we know even less about it than we thought.
Absolutely.
More questions than answers.
One
Well,
of
we
the
know
things.
water is programmable. That's what we know.
We
Yeah.
know that it's definitely susceptible to subtle energies, and subtle energies constitute cognitive intent and electromagnetic fields and thermal energies that are coming off of a living being or even a plant. Just being close to something else will entangle two things together.
And
Yeah,
at
they've
a
seen a
bigger
lot of easy
scale.
water structures that actually communicate at a distance. That's the work of Luc Montagnier that you're referring to, right?
Sorry, will you repeat that for me?
Oh, like I think Luc Montagnier did some experiments like that where he created the water memory and they were separated spatially and that they were able to interact with each other.
Yeah, he did that. There's several labs actually in Canada. Dr. Persinger in Sudbury at Laurentian University. They've been doing experiments as well where they're able to entangle two separate containers of water using an electromagnetic field, a pulsed magnetic field that's patterned, and present it around these containers of water. And by introducing acetic acid to one of them, while they're both under this magnetic field, spatially separated, they're able to induce pH change in the water that's not receiving any acetic acid just because they're entangled, because there's an electromagnetic field allowing for this entanglement to occur. So
And just for the audience to know, Persinger was actually Noah's advisor back in Ontario.
yeah, I conducted my graduate work with him.
Ironically, one of the experiments that was classically performed by alchemists was to look into water to see themselves. And what you were just saying is a way to see oneself as the conscious observer, and the water is programmable. And when we can create that special field of energy, which is through the conscious application of the sacred, which is love, which is that background frequency that defines sentience, how science and the conscious application of the sacred come together, that's our joining. That's the future. Why? We understand through the LeClaire effect that all of this is transmutable and possible. It's a matter of understanding it and devising conscious technology and the respect for it, because there's a great deal of respect for the radiation that can be done, how it could damage our world in none ways yet seen, and yet could it be limited simply because we are beings coming out of the limitations of our past. And we
I
can't
think
have those same limitations in place.
I think many of us here would agree that the experimenter themselves has an effect on the water itself and the experiment. But let's not get into that now. I think we can all smile and shake our head, nod our heads at that. I have a question from Facebook. Does the spiral geometry have anything to do with torsion field energy? Perhaps a heretical question.
I'm not sure what torsion field energy is. Maybe you could define that for me.
That's another great question. Torsion is the name that Russian scientists have used really for the ether and such. But
Ah,
but maybe that's not the question for the time. I understand. We'll pass on that one. Another question by Colin Schmidt. What's up, Colin? In addition, the sharp edges of the metal have more electron density, probably attracting the positive crystal. I wonder if sound-formed bubbles would also give the same effect.
yeah, anytime you form that crystal interface like that, because even the inside of the bubble can form a crystal layer. And I've seen pictures of cavitation bubbles that look like buckyballs. So they look like soccer balls. You can see facets on the outside of this. This is other people's pictures too, not mine. So I mean, it's forming that crystal interface at the final point of collapse. As soon as it gets above a high enough pressure to be able to push those atoms close enough together because they're trying to repel each other. So it overcomes this really intense repulsion in order to form the bond. That's why you don't see the crystal ordinarily. It does form in nature, but it forms more often in my apparatus because the bubbles actually collapse further than they do in nature. You know, they don't. The jet ordinarily in nature will strike the surface and then disrupt the final collapse of the bubble. But in my case, there's a hole there, so the jet passes through, and the bubble collapses completely to a dot and hits the maximum pressure that it's able to hit with cavitation that you just typically don't see in nature. So the crystal will form 80 to 85% of the time when I'm doing this cavitation work. I see it all the time. Very common.
Wow. I have a question for you. It might be a silly question, but Brownian motion, you mentioned that in your paper on cavitation theory of life. Can you tell us where Brownian motion factors into the LeClaire effect? There's a lot of clarity on that in general.
Well, what I was talking about there is the fact that it's isolated from Brownian motion because it's going supersonic speeds. And so anything that's going supersonic speeds of the shock waves surrounding it doesn't feel the downstream conditions. So if there's Brownian motion trying to shove it around, the pressure gradient doesn't allow that to be transmitted backwards on the thing. So the result is that it's isolated from Brownian motion and it makes a nice straight trajectory through the fluid. But that's actually all I referred to in the paper.
Okay.
I have
a
tangent.
There's a very interesting, I'm going to take a quote right out of your paper right now. It's very interesting, and I really want some clarification on this one from you. And I quote, "It is interesting to note that a water-based 1 nanometer diameter, regularly ordered hexagonal crystalline re-entrant microjet fits perfectly into the 1 nanometer wide minor groove of the DNA B helix."
Yeah, that's absolutely right. In fact, let's jump right to that picture right there. So what you're seeing right now, there's the minor groove, and the major groove is the wider of the two. And it turns out the minor groove is exactly a nanometer across in this direction. Well, if you have a water crystal that's that size, you get a one-to-one correspondence with all the rungs in the ladder of DNA. So the result is that there's a place for the crystal to bond temporarily to act as a scaffold for this thing. And you can see these are the connecting points here. It connects onto the phosphates and the bases. And the result is that it's the perfect geometry to fit into the groove. It's the perfect geometry to go from rung to rung. And in fact, if you see these layers that are forming here, they're exactly the thickness of a water molecule. It's 0.3 nanometers between each of the rungs. And so a water crystal happens to have the perfect geometry to be able to act as the template for RNA, DNA, and also protein. Now, there's actually a 2-to-1 correspondence, like it jumps every other bond on the crystal to form DNA, and every bond distance for forming protein. So 1-to-1 for protein, 2-to-1 for RNA and DNA. All right, so it's the perfect crystal that kind of like, it does everything in terms of forming both the nucleic acids and the proteins, which really is interesting because it's kind of a chicken and the egg problem. I think Noah could fill you in better on this, but basically you can't form proteins without DNA and vice versa. So which came first? I say they came together.
Wow, Noah, do you have anything to say about that?
I don't know if I can comment on that one. That's not exactly where my specialty lies. But I did note that that spot in your article as well, that reference, because I think you mentioned it in one of the papers of yours that I was reading recently. You point out that the re-entrant jet could puncture a cell, introduce material into the cell without actually rupturing the cell, so that it would be able to maintain structural integrity and hold this new information inside of it and incorporate it into itself.
Yeah,
which is fascinating.
There's actually a study that was done by a group at Duke Medical, and they unknowingly infringed on my patents And what they were doing is they were using the double bubble version of my patents where I formed two cavitation bubbles. And they formed a Rancher jet that they aimed towards the cell, and they injected blue trypan dye into the cell, and the cell turned blue, but it didn't kill the cell. So they
Mm-hmm.
put a 200 nanometer hole into the cell membrane, and but they did it exactly following step by step the exact procedure that I outlined for doing targeted drug delivery with that technique in my patents. So I mean, other people are stumbling across the same thing. People in the cavitation field are just starting to catch up, and I'm a decade ahead of all these guys.
So, just so people understand, practically speaking, this drug delivery mechanism, what could it mean? Just explain it to us like
Well,
we're a 6-year-old.
imagine injecting like genes that you need for gene therapy, so you're replacing bad genes with good ones. So you want to get those genes into the cell without hurting them, and you don't want to kill the cell. That allows that to happen. So targeted gene therapy now becomes possible without causing a lot of collateral damage. And in fact, when that article came out, it came out in physical review letters on the Duke Group, and the editor in chief, who's Gene Sprouse, he's really famous. You see him in Scientific American mentioned all the time. Well, it turned out that he did a special editorial review on that and decided it was one of the most important papers that had graced the pages of physical review letters. But the problem is they decided not to mention me. They didn't do a thorough background check in terms of the existing patents, which describe it exactly. So basically, it was plagiarism. And I told Gene Sprouse that it was plagiarism, and he ignored me, and nothing ever happened because it's the good old boy club with Duke, apparently. And I put them on notice they're infringing too, and they just ignored me. So, I mean, there doesn't seem to be much interest in, giving credit where it's due with these guys, that if they didn't see it in a scientific paper, and it happened to be in a patent description, well, one's prior art just like the other. So they're not, number one, they're not going to get any patents surrounding it. I already own all of them.
It's also fair to say that this technology, from gene therapy, could also be used to repair bones, repair skin, generating the exact material that you would need for the body.
Mm-hmm. Yeah, doing tissue scaffolding and all that, where you can
Yep.
pop holes through to allow blood flow vascularization. I mean, all
Yep.
these things are possible. Doing
Nanovascular
microsurgery.
surgery.
Yep, going in there and cutting away thrombus, and in fact, they use cavitation in catheters now, but they're harnessing the shock of the implosion of the bubble, not the reentrant jet. So I've proposed a whole new class of catheters where you can go in there and do microsurgery by being able to, like a scalpel, being able to aim the jet and do what you need to do with it.
And just peel off the crust on the inside of the veins, the arteries, even cell walls, and use it to filter the cellular material that's going through the hemoglobin.
Well, taking it to the extreme, imagine a nanobot armed with a little canister of
Yep.
positrons and creating cavitation bubbles and killing viruses and other
Yep.
invaders
Yep.
and forming
I mean, you take it all the way
ultimately,
up to yep.
yeah, artificial
As well
immune
as
system.
modifying your DNA, where you could self-repair your body based off of your conscious interaction with the technology.
Well, imagine instead of catching a cold, everything that comes into your body that's a foreign invader bumps into it, does a DNA check. If it doesn't belong there, it takes it out.
That sounds like a practice technology that any alien species that would want to come to a new world would have built into their blood.
I think that's ultimately what's going to happen in terms of, like, you look at how cybernetic people are becoming with time, and that's just another step.
Well, if anyone wants to leave this world, I'm sure that that's going to be necessary. I mean, we're not going to take our sicknesses there because, we're all a toxic world here. I mean, you can
Yeah,
only imagine what our GMO corn will do to someone else.
absolutely.
So we have other questions and
Yes,
people behind
Mark,
the
I
scenes
have a
that want to
question
try
for you.
and address my audience and keep these guys happy and
Yeah,
get a little
I have
info.
another question for you, Mark, if I will. I've been, in reading your paper, there was one other sentence that really, a whole paragraph actually, that really blew my mind. I'll read just a short portion of it, and you'll get it. A quote: "Amino acids have also been formed from plain shock waves in shock tubes. Shock waves are generated by cavitation. In general, it is very easy to generate acids which can form from a variety of energy sources, including electron beams and simple heating." Tell
Yeah,
us a
in
little
fact,
more about that.
that's the work of a professor named Ken Susslich at Urbana-Champaign. He's a sonochemist. And he's discovered that you can form all sorts of proteins and all different types of configurations, including small protein spheres, which he claims, could be act as a cell membrane precursor, say. And so, it's obvious that through the action of sonic chemistry, you can form not just molecules, but large structures, that are on the order of the size of cell membranes. So they're thousands of times larger than the atoms and the molecules, right? So they're forming these large-scale structures like cavitation is used to produce a thing called a liposome, where they bust up cell membranes, but it reassembles itself into these spherical proto-membranes. It's just an empty vesicle. And they'll put drugs inside of those and use them as delivery mechanisms to go past the blood-brain barrier. And so cavitation creates artificial membranes. Right now, that's a common commercial application of it. And so you look at the origin of life, and you got to ask yourself, well, hey, if you can create an artificial membrane, how about a real one?
Absolutely. The implications for that, I mean, just seem absolutely amazing. I mean, just practically speaking, what could happen?
Yeah, I mean, I can see analogies in cavitation dynamics where it does, like I say, not just puts the pieces together, but really assembles it all, which is the missing part of this, that you look at other original life theories and how far do they really drill in terms of coming up with the details and how it would have happened. I mean, what competing theories are like? One of the most popular ones is that life started on a piece of fool's gold.
It seems that with with the combination of transmutation, plus being able to penetrate cell walls without harming the cell, and plus the creation of amino acids and cellular membranes, and we're almost looking at like replicator, Star Trek replicator type reality in the future if we were to really embrace cavitation. Is that too far out?
Well, that's what my PhD thesis at WPI, they actually accepted my candidacy plan, and that's exactly what I was going to do, is to form life from scratch.
You're really taking it back to like the ancient Arab alchemists and like the Jewish rabbis trying to make the golems.
That's my man, the alchemist himself, Mark LeClaire. That's right. That's awesome. That's absolutely awesome.
You have to call me Frank Einstein.
So, Noah, what do you have to say about that, Noah? Is that too far out, you think?
No, and it's always been my dream to create life from scratch, so I'm right with you, Mark.
I think it can be done. I mean, they're already doing it right now. In fact, I was reading Scientific American this past month. There was an article on the origin of life in there. In fact, it was Chris McKay, who I've had long conversations with too. He's an astrobiologist back at Ames, where I gave the presentation. Now, he didn't necessarily agree with what I had to say about cavitation, but kind of like took it with a caveat and thought, well, yeah, I probably added some of the precursors, but didn't agree with being the central part of the theory because he was kind of, in my opinion, too hung up on the smokers, the bottom of the ocean.
So I've got our first Facebook meme from this thing, caveat cavitation.
So Andrew, what do you think? I mean, do we have at least 2 heretics here? I mean, it sounds like
we have more than a few heretics. We're a heretical organization charging even heretics out there, going, you're pushing the envelope. But this is necessary because exactly what Mark is talking is transmutation. And when people dissect this interview over a period of weeks and weeks and weeks and understand the spiritual side, which is the alchemist, which is information that's been passed on through metaphysics, it's the same thing. It's just done by guys who had a pump they made themselves instead of getting at Home Depot. And yes, they got exposed to radiation because you see all sorts of alchemists with radiation burns all over them.
Oh, sure. In fact, you got to think about it. How hard is it for the ancients to build a pump? I mean, I'm sure they had cavitating pumps back then, especially poorly designed pumps tend to cavitate anyway, right?
Yep. Exactly, and they show it in their texts.
Right. So, I mean, the odds of the Arab alchemists having transmuted materials, in my opinion, it's 100%.
It's the philosopher's stone. It's whatever you want it to be, whatever it is you need to manifest.
In fact, the philosopher's stone and phlogiston, right?
All of that.
I think the philosopher's stone might have been a porous stone that they were forcing, a cavitating flow through, right? Or is forcing it to cavitate because of the porosity. Could have been something that simple.
Exactly. Could have been something that simple. Backyard scientists have been doing this. Whether it's the creation of gunpowder, which was thought to be a virility drug, and turned out to be different kind of virility for mankind to have, and now you have cavitation, which has been shown in alchemy over and over and over and over and over again. There's thousands and thousands of texts from alchemists throughout the 5th to the 15th century that talk about cavitation. They just present the language different because they were hiding it from a church.
Well,
And
you know, the
science was
transmutation
studied.
part of this thing is critical because if you look at the other original life theories, not one of them mentions transmutation of the elements, so it's not really a part of the other theories. So it has the right stuff. You know, it's producing the elements, it's producing the template, it's accelerating chemical reactions. All
It's
these
happening
things
in
are
water.
happening. Yeah, and it's all happening in close proximity to each other. I mean, none of these things, I mean, it goes into so much detail and depth in terms of the theory, and it's all very testable. So we're going to find out the answers to this because eventually all these things can be easily tested in proper laboratories. So you're going to see the answers.
So, Tech, last show you were talking about getting a GoFundMe campaign going and stuff like that. That'd probably be a good time to do it. We're nearing about 2 hours for the show. So why don't we either take some more questions or do some of that stuff that we said, like the GoFundMe and where to go to find more information for everyone?
Well, there's no GoFundMe campaign right now. We still have to work on things like that. But, you know, I think the most important thing right now is to get the people into this, get Mark some feedback, you know, get people really engaged in this, because this is a whole new world that Mark has opened up. You know, he's not just one guy looking at one little thing. This is an entire new phase. So I really want to bring people in. Like, what I like about what you're doing, Andrew, is you're talking about crystals and the metaphysical and spiritual side. I think that's very important. I'd like to get the opinion of a musician, Tahvul Garcia. He's an Aether Force member, and he's just getting a grant from DARPA. Could you unmute Tahvul for a second, Andrew?
1 second. Well, I think he's got to unmute himself now.
Tahvul, could you unmute yourself, brother? I don't have my mic on. All right, we'll get his input in later. But no, there's no GoFundMe campaign right now. I just want to say this has been great, and I'm awed again, Mark. I hope we can continue to do this and continue to build this dialogue with the community, get more and more young minds excited about the humble water bubble.
Well, you know, I think the important thing here, and the reason why I wanted to do the original life as a follow-on to the fusion, is because the two march hand in hand. There's a lot of synergy that's going on here between the two. Is that it makes it a lot more believable to believe the original life theory is based on cavitation if the transmutation and fusion are occurring, and then vice versa too. Is that, you know, the fusion becomes a lot more believable if you think that, well, cavitation generated life, you know, and you need all these supernova distribution elements. Well, where do they come from? So one kind of points towards the other, and I think the whole thing becomes a lot more believable, you know, both the fusion and the original life when you take them together.
Absolutely, absolutely. You're seeing a certain synergy between biology and, you know, physics. That it's all happening in water too. That's another thing that people need to understand, how potent and how powerful water is. And one of the things I like about Dr. Pollack's book is that he gives two examples in the beginning about the suppression of water, the whole polyphase debacle. And Noah, you've read the book, Noah. Can you tell us a little bit about the suppression of water science? I know Mark has a lot to say about that, and he can name names. We don't want to go there.
That's a long subject, so I'll be brief. But generally speaking, in the polywater debacle, which you already touched on, was probably the main reason why water science was depressed for a while. And in that, the whole water memory idea that water has a memory, that water can change its organization based off of previous molecules that have already been introduced to it, that magnetic fields can have an effect, that subtle energies can have an effect in the way that water is organized, in the way that water interacts with organic substrates. That was looked down upon by the other sciences for quite some time. So actually, when I did my undergrad, which was applying a magnetic field to water and then introducing an aquatic flatworm to the water that had been treated, I brought it to a professor who laughed at me and told me that there was no way that magnetic field could have any effect on water. He was wrong, I'm happy to say, because otherwise I would have no thesis for my undergrad. But that was hurtful for me as a young blooming scientist at the time. So it's everywhere. It's just water is thought to be one of the most simple molecules that we know of, and the truth of the matter is it's the complete opposite. It's the most complicated, mysterious molecule that exists on our planet. We don't understand it, and it's ubiquitous. And that in itself is a huge red flag. How can we understand the planet or ourselves or life if we don't understand the fundamental unit of all these things?
You know, I'd like to point out that Noah raised an important thing that I want to focus on, which is polywater. Most of you don't remember, but there was this thing called the polywater scare about 20, 30 years ago. I can't even remember how far back it goes. But it was
Wow.
Andre Lipson was the scientist behind a lot of that, and he's actually a friend of my partner Serge Levitt's. And so they're using high pressure with capillaries, and they formed what they claimed was a polymer form of water. But guess what? Regularly ordered monomers into a polymer like that is also the structure of the crystal. Because this crystal is actually a polymer, the monomer is the individual water molecules. All right, and so you've got polymerized water here. So I'm saying that what I've done really is I've rediscovered polywater. And in fact, I think Andre Lipson, to give him credit, was probably the first one to ever see the water crystal and describe it. They couldn't reproduce it to everybody's satisfaction, and the result is that it ended up getting ridiculed, as Noah pointed out, and it kind of muddied the waters for a while in terms of advancing the field. But honestly, they were pioneers, and my hat is off to Andre Lipson, God rest his soul. As some of you might realize, that he died of a heart attack just before heading towards the University of Missouri group that he was going to join as a professor. And I've got some things I'd like to say about that too, that I don't think Andre's death was natural. You got to be careful when you hang out with the cold fusion world, because a lot of the people, that have ended up dead in this field have been hanging out with the same group, who I won't name, but I think TechZ knows who I'm talking about. But they have a very bad habit of dying after spending a couple weeks with these guys, and suddenly they end up with blood disorders, heart attacks. There's been a lot of common thread involved with that, and that's what I have to say about suppression. Is you have to watch yourself. Is that anybody in this field, the powers that be don't want to see science advance past the basic level that's being presented right now. That they know that Newtonian physics is dead. They just don't want the rest of us to catch up to where they are. They want to leave us behind in the dust.
Strong words, brother, and beautiful words. I think all of humanity will be playing back that short clip there. It'll be resounding. We look at this meeting here, just a bunch of friends getting together and discussing science, as just another meeting, but it really is the beginning of something beautiful. And I'm very, very proud to say that I could actually converse with you and be a part of this. And that includes everyone here, Andrew, Noah, all the Aether Force members, everyone listening to this right now. Thank you so much, Mark. I respect you a lot more, I got to say, for your courage than even for your brains. I think cajones are more important than brains these days. So I'm thankful you've got both.
It takes a lot of guts in this field. It's not for the faint of heart.
Absolutely. And all you're doing is just messing around with water.
I mean, even Noah, with easy water and all that, I mean, she runs into the exact same troubles, that there's a resistance to new ideas. That, how can you call it science when you're not willing to entertain new data?
Absolutely. Beautiful Noah that got her heart broken by some jerk professor. I mean, that's real right there, In addition, Eugene Malov, he was one of the biggest proponents of cold fusion. And he gave an interview on Coast to Coast Radio where he started talking about that. And then he brought up the ether. And then he was dead the very same day, beaten to death in his home. So we've got a lot to take down, to fight and just to hold down. But it's a spiritual
battle. Well, I can tell you that we've spoken in confidence with some of his relatives, and they don't believe that was a natural occurrence either.
Absolutely.
So, that wasn't just a coincidence. I mean, he was cleaning an empty apartment out, and two guys show up to beat him to death. They claim that they were there to steal, but it's obvious that's not the case.
Absolutely.
With that being said, everyone, we want you to encourage you to go to Aether Force, to go to Facebook, to go to everyone's websites and start links and chats here. You can go to the main webpage link at the top here, or link to Google Hangout. Please go to your blogs. Post this link in the Science Place. We encourage everyone that's listening, all those future audience that are coming in. Here's your chance. He has proven transmutation, proven cavitation. He's prove. From this point forth, it's about stepping into the power, stepping into the legacy that's represented from this understanding of this incredible science, this incredible wisdom, and how science and wisdom can take us into the future. It'll take all sides of the rainbow for everyone to come together. I encourage you, start threads, start posts. We intend to do some kind of a regular broadcast series here. Please go watch the first episode on Blog Talk Radio with Gustav Molina, myself, and TechZ. It was another incredible event. And ladies and gentlemen, there's more and more cavitation to come. So, Mark, why don't you give out your website info, and then Noah and Tech also, and we're going to call this a show because we've got some amazing, amazing stuff here for people to digest.
Well, my contact information is my website is www.nanospireinc.com, NanoSpireinc.com. And it can also reach me by phone, too. I'm pretty good in terms of picking up the phone and talking to people. As some of the viewers from the previous show found out that I keep my word, and if you want to reach me directly, I'm approachable. And I want to get the word out, and I want to talk to people, and don't feel like any question is too dumb. I'm interested in answering people's questions, hearing their insights. So you can reach me at 207-929-6226 is my phone number, and I'd be glad to hear from anybody.
I absolutely want to vouch for that. The first person I spoke to when I got onto alternative science 2 years ago was Mark LeClaire. I just called up the number on his website, and I thought, oh, this guy who's just figured out how to transmutate everything, he'll never answer my call, never talk. He answers the phone right away. He's like, hi, who's this? We start talking. He answers every single one of my questions patiently, and it was just awesome. So everyone, yes, please, Mark LeClaire, he is brilliant, but in his own mind, he's just a normal guy. So just give him a call and say hi. And if you can, stop by Aether Force, etherforce.com, AETHER Force. We're an interesting little community. We're trying to bring things together, and we don't back down from a fight, and we always back up our friends. We've come under the same attack that everyone else has, and that Mark has. But we're still here, so thank you very much for supporting us. And thank you again, Mark and Noah. You guys are awesome. And Andrew for hosting this and the entire New Earth project. I encourage everyone to check out New Earth. There's some really amazing people in New Earth. They've taken me into their homes. They've, just offered me so much help. It's really a family that's coming together. And that's really what's going to win this, La Familia.
Well, absolutely. In fact, I want to point out, thank you, Santi, thank you, Andrew, thank you, TechZ, thank you, Noah. I mean, you can't take things like this forward being one person. It takes a team to take new science forward, and I think Noah understands that, you've really got to try to build a consensus. It takes time, and it takes energy.
I agree 100%. Collaboration is the only key. It helps us move forward as a collective. Otherwise, we'd be spiraling.
Yeah, united we stand, divided we fall.
Exactly. On that note, anyone who's willing to reach me, please do so. You can email me at noah.gang@gmail.com. It's spelled NOA.GANG@gmail.com. And I'll answer any emails that I receive. I'd be happy to get some.
And I'd also like to point out for TechZ that we're going to also do some follow-on shows with Aether Force too. So just to let you know that you'll be able to see us drill down into more detail both on the New Earth Radio and then also on the Aether Force show, which TechZ is in the process of setting up now.